Let's leave something that doesn't have notifications. Oh, that's the wind. Well, we probably can't wait too much longer. Well, I'm waiting for you to leave now. I'm waiting for you to leave. Not any of you. Her.
Where's Ben?
He's at a sleepover with Brittany's parents. So if he had his way, we'd never see him again. He he enjoys it. There's less rules, and he doesn't get in as much trouble there because he listens to her parents more than he does us. But and he enjoys it, and it gives us a break because, well, 4-year-olds are a pain in the butt. Well, it's been a few minutes. We've started that. We'll do this. Include system audio. All right. Yesterday we did converting mastomoles and all of that. I said I would do these two. So I added up that FESCN twice a minute ago. 0.0184 moles of this nice red iron 2 thiocyanate. I'm given moles. I want to find grams. So I want to put moles on the bottom because I have moles. And I want grams. 172 because you've got 2 sulfur, 2 carbon, and 2 nitrogen. We would actually have gotten to CFESCN twice if we weren't stuck at home. Because I had Miss Cook buy some, well, 3.16, the stuff to make it. So 3.16 grams, 1, 2, 3 significant figures, 3 significant figures. Let's see, did we pick up anybody else? Oh, we've added, I think Caitlin's the new one. Zinc chloride going from grams to moles, 0.972 grams. Zinc chloride, want to get rid of grams. So that means moles goes on top. 1 mole added up earlier, 65 and 35 twice, plus change, 136.31. 0.972 divided by 0.00713. So I put up earlier today these 6 questions. Give the molar mass, the mass of 1 mole, to 2 decimal places of those 4 things. 3 of them should be fairly straightforward. 1 you have to think, find the molar mass of blah, 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 blah. potassium bromide, ammonium selenide. Now, I, well, you're going to have to do it down here. You have to figure out what the formula for zinc nitrate is. Well, that's sugar. Those are the two 22.4 ones. Um, but it's just kind of adding stuff up and doing a little multiply and divide. And there is, well, those are the those are the answers to the questions from the textbook. And apparently how to do 17. Um, that was something at some point. There is this percent composition stuff. There's empirical formula. It's an application of moles and mass and all of that. Uh, but to make sure we get through equations and stoichiometry and concentration, I'm going to, if we have time to come back to this sometime, we do. If not, well, it may be something like this is particles to moles, molar mass, volume to moles, percent composition. Like that's the stuff that we were supposed to do. But time is of the essence. So I should have posted, I think I did. Um, Somebody left. It's unfortunate. Because I remember at one point we had like 10 or 12 people. I know, but that's why we're recording it. I get more assignments. Reactions. So the first kind of little bit of this is technical. Part of the skeleton things is um, basically naming. And then we have balancing to do. And I posted all the way up, I think, to there. And then we'll quickly talk about types of reactions, single double replacement, predicting products. I don't know how much exactly we'll do, but a chemical reaction has two parts. The reactants, the stuff you start with, and the products, the things you produce. You react two things together and produce other things. Well, not necessarily two things, but the things that you start with. Reactants go to, and it's just all a matter of how they are written. So the next little couple points, in a reaction, in a chemical reaction, because we can have nuclear reactions, we can have physical changes, but in a chemical reactions, fundamentally, all we're changing is how things are joined together. We're not changing atoms, we're just moving things around. I can communicate this. Copper reacts with chlorine to form copper 2 chloride. Words with changes reacts to 2 plus and all of that. There's some symbols that you'll see in different spots. The arrow reacts to, it's copper plus chlorine reacts to form copper 2 chloride. Sometimes you'll see SLG and AQ at the end of particular compounds. Whoops, it would help if I had an actual pen. An S means solid, a G means gas, and L means liquid. AQ means dissolved in water. It's a solution. So if you're somebody like me who, when you get a sore throat, you take some salt, not NaL, but NaCl, you dissolve it in water. If I had the ability to write properly, I could say I have an aqueous solution of salt. Sometimes these are kind of less common these days. If you have an arrow at the end of something, it's the same as a gas. And an arrow up, sorry, is a gas. An arrow down, because a gas kind of bubbles to the top and the solid sinks to the bottom. Other signs you may see, this you'll see if you take Chemistry 12. It's a reversible reaction. Not every reaction just goes in one direction. Some can go in the other direction. But that's a whole unit on equilibrium in Chemistry 12. If you see a little triangle or the word heat, you have to add heat. Something like a compound or an element on top of an arrow is a catalyst. So your body has a whole bunch of catalysts that break down things. If it wasn't for catalysts in your body, um, we wouldn't actually survive. You can kind of think of the hemoglobin in your blood catalyzes the breaking of an oxygen. Well, I don't think technically it does. That's a bad example. Your spit has different enzymes. Oh, hey, down there. Um, are proteins that help you do different things. This platinum one is one that's common in what's called the hydrogenation of alkenes, which is adding hydrogen across a carbon-carbon double bond. So that's just terminology. We start with a skeleton. If I were to give you, here's something, convert this into an equation, which we'll do a couple of. We're not really going to go the other way. A skeleton is just what compounds are there. Solid iron 2 sulfide reacts with gaseous hydrogen chloride to form iron 2 chloride and hydrogen sulfide gas. So we have four things, and then we've got this 2 form. So iron 3, that means I've got iron plus 3. Sulfide is minus 2. So I would write Fe2S3 reacts with plus gaseous hydrogen chloride. This is H plus 1, Cl minus 1. Oh, technically we should put an S because it says solid. HCl, AQ, and gas are two different things. So there's my reactants. 2 form, arrow, solid, iron, plus 2, chloride, minus 1, and hydrogen sulfide gas. So this is, we call it a skeleton. It's the basic thing, but the problem with a skeleton is we've got 2 irons here and 1 there. We've got 3 sulfurs here and 1 there. I've got 1 chlorine and 2 chlorine. In kind of how an actual reaction happens, it's similar to when we formed how does, well, iron is a bad example, but we had aluminum with its 3 valence electrons and sulfur with its 6, and drew our arrows to form compounds. We need to balance it because we have to have the same amount of stuff on both sides. If I were to do this quick, which is, you should have seen balancing, 3 of those, 2 of those. That's not going to work. So I'm going to change that to a 2, that to a 4, that to a 6, 8, and oh, that's not going to work either. Oh, why is this not wanting to balance? Should. It usually does. Let's keep. Oh, right, that doesn't want to work. Three sulfur is the easiest. 2 times 2 is 4 chlorine and 6 hydrogen, so that's a bit of an issue. This might not be balanceable because that's plus 3 and that's plus 2. Throw 4 there. 8. So that's 12. That's still 16. I'm going to have to figure that one out later. And that doesn't want to do anything. It could be just a dummy equation. Nitric acid is HNO3 dissolved in water. Aqueous reacts with solid. This will sodium carbonate to form liquid water, carbon dioxide gas, and sodium nitrate dissolved in water. This one should work. I need two of those, two of those, two, 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 two sodium, CO2. Yeah. So that one balances a little better. I don't know why that one up there didn't work unless I messed something up. We could write them out the other way. And that's what that particular page is. But that's naming compounds. It's practice you can do if you would like, for those of you who have showed up. What we really need to be able to do in the first part of this one is balance equations. Atoms can't be created or destroyed. For the most part, some atoms fall apart on their own, but for chemistry, that's I'm concerned about this because we're not doing nuclear physics. Atoms we start with, we have to end up with. So a balanced equation has the same number of atoms of each element on both sides of the equation. There's all sorts of different tricks. If I take carbon, react it with oxygen, and make carbon monoxide, one carbon, two oxygens, one carbon, two oxygens, it's nice and balanced. Now this, I wonder if I move this one. Arg. Oh, there. This is supposed to be nifty that I can do this. If I do the same thing and make carbon monoxide, well, I've got two oxygens here and one here, so I can add another oxygen. Well, now I've got two carbons and one carbon, so apparently the second one isn't grouped together for some reason. So I add another carbon. So that's fundamentally what we're doing. We just kind of keep adding things. So the actual equation is, well, it's under here. 2 carbon plus oxygen gives 2 carbon monoxide. So balancing is done in Science 10. I know Madame Walsh does it. I assume whoever else has Science 10 in English does it as well because it's one of the fundamental things. Rules for balance. Write the correct formula. Normally for balancing we give you the equation. You just have to do your counting, count the numbers, balance the elements by adding coefficients. You are only changing the numbers in front. You never change a formula because then you mess everything up. So never change subscripts. If you change a formula, you have a different reaction because, oh, well, if you need an extra oxygen and water and you make it H2O2, this you can drink, this you can't. Water, good. Hydrogen peroxide. A 3% solution is probably not, which is what you buy in a store, isn't going to hurt you that much. It's probably not good for you. But the higher concentration stuff, you can actually bleach your skin. Where you always stick stuff out front. And that's why that one from the other page is going to perplex me um, for a number of days. I think I know why, but so examples how I start these on both sides. I have hydrogen and oxygen. So we've got two of those. two of those. So the first thing, count what you've got. Okay, da 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 da. Which is the problem? Well, the oxygens are not balanced. So if I add a coefficient, I put a 2 in front of there. So that's going to change this to a 4 and that to a 2. So those are balanced now. These aren't. So it's a balancing. You kind of add stuff to each side until everything works out. So 4 and 2, I can add a 2 there. Doesn't change the oxygen. Two 2's make 4. So 2 hydrogen plus 1 oxygen gives 2 water molecules. And these can get ridiculously complicated. They can be fairly straightforward. Some of the ones on the next couple of pages, you actually don't have to put any numbers in. It just kind of works out. The first one you do, but so how I usually do this is just, it's examples we would normally have people come up and we would work through them as a group. Same idea. Eventually, if you're 100% confident with this and you don't have to list these and you can just say, oh, I've got 1 carbon and 1 carbon. Well, that's good. I've got 4 of those, 2 of those, 2, and 3. So this is technically a combustion reaction. This is how you burn methane in air. So if I'm looking at one of these, let's get a hydrocarbon and oxygen. This is what we'll leave until the end, because if I can balance the carbons and hydrogens, if I add a number at the end to O2, it's not going to mess anything up. It's about, generally speaking, when you have an atom on its own. Well, that one is kind of the same. Leave that until the end. So if I'm balancing this, carbon is good. I've got 4 hydrogens here. Well, I don't want 4 hydrogens. I need 4 hydrogens on that side, so I'm going to stick a 2 there. Doesn't change carbon. Now I've got 4 hydrogens. 2 plus 2 is 4 oxygens. So if you change one compound, you have to change however many elements are in it. So I've got that. Carbon is good. Hydrogen is good. Now I've got 4 oxygen here, 2 oxygen there. I can just... Well, like initially. So initially, before I put that blue 2 there, carbon dioxide has 2. Water has 1. So that gives us 3 initially. So that's where these combustion ones you got to watch out, because it's got oxygen in different spots. So these are ones that can get tricky, but there's different tricks that we'll talk about in the next few days. So now if I add a 2 there, that gives me 4, 1, 4, 4. Sometimes I get really picky with putting ones in there, but most of the time, if you leave it without a number, well, that you're not deleting it. It's not like putting a 0 there. So I'm going to do a few more. This one has a polyatomic ion, and this point over here, if there's a polyatomic ion and it's the same on both sides, I've got NO3 and NO3, you can actually treat that as one thing. So the 2 metals are silver and copper because they're both, whoops. I usually will want to keep these in the same order. So because this doesn't change, and when we're balancing, I'm not super, technically it's NO3 minus, but the atoms are different. It's silver plus and all that, but it's types, 1 silver, 1 copper. As a group, there is 1 NO3, 1 silver, 1 copper. Now as a group, there's 2 NO3s. You can split it up into nitrogen and oxygen. If it switches from side to side, you have to split it up. But because this is NO3 on both sides, well, this is the kind of issue. So if I put a 2 here, I now have 2 silver, 2 nitrate. So the nitrates are happy, the copper's happy, so I only have to worry about silver. So if I put a 2 there, that becomes a 2 and balanced. So far, so good. I'm going to quickly run through. This one should be fairly straightforward. A, L, and N. 1, 2, 2, 3. So balancing the aluminums is fairly straightforward. I actually wouldn't start with aluminum. When we have this situation here, where those are more or less a 2 and a 3, odd and even, I can't just put one number in here and have everything balanced. So this is another instance like charge. We look for a common multiple. Well, the lowest common multiple of 2 and 3 is 6. Really, we want to make the odd number even. So if I put a 2 here, that becomes 6. Now I've got two even numbers and it's fairly straightforward. That becomes 4. Now we can do either one, but I would look at this first, 6 and 2. We'll throw a 3 up there. So that's now happy. And we get 4, 3, and 2. Where people run into trouble is if you actually have a multiple or a common factor between your coefficients. If you did 8, 6, and 4, well, those are all divisible by 2. If you do something like that and realize, oh my gosh, I've got all even numbers and I can divide them, you can divide them at the end. But if you did 8, 6, and 4, I would technically mark it wrong. P-O, P-O, 10, 2, 1, 4. This one is because it's just two elements. 10 and 2 are okay. That becomes a 5, makes that a 10. 4 makes that a 4, and everything's balanced. Well, this is if you fix everything but one element, it's even on one and odd on the other. You can double stuff to get rid of those. Water is different. Even though it is like the order, I keep the order the same on both sides because I don't want to one. So an instance where we have a 3 and a 2, but this is problematic because I've got hydrogen in 2 spots. Hydrogen is the only problem. Nuts. I don't know what I was just going to erase. So maybe it was this. So that's on its own. I'm going to leave that one be because if I change this one, I'm going to have to deal with other things. I can't just end because that's got an even number. So myself, bam, I'm going to put a 2 there. So that gives me 2 sodium, 2 oxygen, 2 hydrogen plus those 2 makes 4. So that's all nice and healthy. Well, 2 sodium, 2 sodium. I can put a 2 there and that's happy. Now, 2, 1, 4, 2. I stick a 2 in front of that. 2 times 2 is 4. 2 times 1 is 2. and then that one is balanced. So this is one, a lot of times you balance one side and have a problem with the other. This is one particular instance that I know. CHO, after I do this one, I'll be done. 4, 10, 2, CHO, 1, 2, 3. So if I was to balance this, 4 makes that 4. I'm going to count the oxygen in a minute. 10, so 5 makes that 10. 2 4s are 8, plus 5 is 13. Well, 2 and 13 don't really jive. So the trick is double that first one. Well, that's going to be 8. That's going to be 20. If I double this one, that becomes an 8. That becomes a 10. This is 8. Because if you double everything else, well, those are still balanced. But now let's look at oxygen. 2 8s are 16 plus 10. Well, that makes 26. Can I balance 2 and 26? 13. I don't know what Madame Walsh talks about. Technically, we've been told, like, if you go to university and balance this, they may not like it because some people will do these with fractions. Technically, from what I've been told years ago, let's just keep everything with whole numbers to make it simple. But if I did one, like I can make that a fraction over 2 because we're talking about moles. So half a mole is an actual thing. So that's a quick introduction to balancing equations for the handful of you that are here, that are always here, or your internet. You guys are the ones whose internet is better. Balancing equations is like naming, it's all about practice. So there are 3 pages. The next 3, I think, are in the thing. I would start with the first one on Thursday. I'll probably come back and we'll go through some of these and then I'll say do a couple more and do a couple more, and because it's about practice. If you can do the first 2, these ones that are a little bolder, when I sign off here, I'll do the answers so you can check them. That last one is a little bit tricky, or there's some that are trickier. The more products you have, I don't know if I'm going to cheat and go find my other stuff from other years. I also have one document that I used to, I can't remember if I typed that one or not. Where did it go? And this is great because you can Google this particular page, 263 equations to balance. This is awesome and epic. Some of those might have come from there. Yeah, there's all sorts. None of them are balanced for you, so you can't exactly cheat. But the group of you, I don't think you're going to cheat anyhow. You're going to do it to get your practice, so I'm not worried about that. But does anybody have any questions? If not, I'm done for the day.
Thank you.
You're welcome.